So I found that one of the hardest things about teaching this section as a tutor is that everyone draws their chairs differently. So some of you guys are going to have like these really bubbly chairs, and some of them are going to be really flat. Some of them are just going to be ugly. Some people are going to want to draw the left-hand chair more, and some people are going to draw the right-hand chair more. And what that means is that I get inundated with lots of questions. Johnny, is my chair the same as yours? Or did I draw the right chair? Okay? And that's why I created this whole new section that isn't in your textbook, just to explain to you guys what's important about comparing chairs. Okay? Because it turns out that there's probably like hundreds of different ways to draw the same chair. Okay? And they're all right. You just have to figure out what's important so you'll know what to look for and what you can ignore. Alright? So when we're drawing equivalent chairs, okay, what we want to worry about is just three things. Okay? Your chair could be to the right, my chair could be to the left, yours could be upside down, yours could be way more flat looking than mine, but there's only three things that really matter. The three things that matter are the distance between the groups. That has to do with how far they are from each other. If the first one is on your 1 position, is your second one next to it? That would be called 1, 2. If they're 2 carbons apart, that would be called 1, 3. If they're 3 carbons apart, that would be called 1, 4. Either way, those are really those are like the 3 different combinations of having 2 things. But either way, as long as the distance is the same, we're already off to a good start. The next important thing is cis versus trans. So maybe you wrote one equatorial and I wrote one axial, but in the end of the day, if the cis and trans is the same, then that's also going to mean that these are going to be the same chair. Okay? So what that means is that if I drew a 1, 2 cis upside down, and you drew a 1, 2 cis on some different carbons, they're still the same molecule because overall the distance is the same and the cis and trans is the same. Okay? Then for chairs that are asymmetrical, meaning that they have 2 different types of groups, then equatorial preference is important too. Because maybe I drew the same chair as you, but I drew the other conformer. Maybe I had a 1, 2 cis and you had a 1, 2 cis, but you drew it with the big group in the axial and I drew it with the small group in the axial. Are those identical? Well, they are the same molecule, but they're called conformers. Remember that they are equilibriums with each other. Okay? Those are the 3 things that we look for. So what I want to do here is, you know what? I'm actually going to do a free response one just so you guys can see what I mean. Okay? So imagine that I'm drawing an answer, and I tell you guys that the right answer is CH3 here and CH3 here. Okay? So I tell you guys that that is what the answer is supposed to look like. But the thing is that you draw chairs differently than me, and you like to draw the other chair. So you were drawing the other chair, and you draw it a little bit different. And what you drew as your right answer was actually a CH3 here, okay? And then you drew a CH3, let me see. And then you drew a CH3 here. Okay? So basically, this is my answer. I said this is the right answer. And then this is yours. And you're thinking, wow, did I draw this right? Do I have the right answer? Or am I just completely wrong? The way that we would compare these is, instead of freaking out and saying, I must have gotten it wrong, I don't know what I'm doing. Instead of freaking out, just say, okay, is the distance the same? Is the cis and trans the same? Okay? So first of all, what's the distance between these 2 groups? Well, if this is my 1, you can pick anything to be your 1. Then this would be 2, 3, 4. So this is going to be a 1,4 dimethyl. Okay? Now let's look at yours, because this is the one that you drew. So you wrote 1, 2, 3, 4. Look at that. You also drew a 1,4 dimethyl. Alright, so you weren't that far off. Now let's look at the cis and the trans. This one, they're both facing up. So this one was cis. This one, they're also both facing up. So this one was cis. So guess what? These are the same compound. They're drawn differently, but they're the same compound. So both of them are correct ways to draw this. I know one just looks more messy and one looks still kind of messy, but at the end of the day, they're the same thing. And that's what I'm trying to help you guys see, because I get asked all these kinds of questions. Is mine the same as yours? Okay? So let's go ahead and do some practice. identifying the following chairs. Are they identical, conformers, or different? So go ahead and try to answer this, and then go to the next video once you think you know.